All right, today, 6.1, we are going to be classifying polynomials. So today's lesson really is not going to be all that bad. It'll be a nice, easy intro back into this. A monomial is an expression that is either a real number, a variable, or a product of real numbers and variables. So monomial meaning one term. So one number, one variable, or one term that has both a number and a variable. A polynomial is a monomial or a sum of monomials. The degree of a term is determined by the exponents on the variables. So when we talk about the degree, we look at the exponents. So we'll see other examples of this, but if you want an example to go in your notes here, a monomial would be something like 3 or y or 5x, something like this, just one term. Those are 3 different examples of monomials. A polynomial would be like if we were to add all of those together. 3 plus y plus 5x is an example of a polynomial. The degree of a polynomial is the largest degree of any term of the polynomial. So each term on its own can have its own exponent, but then if we're looking at the degree of the whole polynomial, we look for the largest or highest degree, the highest exponent. All right, the standard form of a polynomial. I think this is probably either a review or kind of intuitive for most people. When the terms of a polynomial are written in descending order of their degrees, then a polynomial is in standard form. So remember, the degree refers to the exponent, and descending order means we go big to small. So we've got the biggest exponent first, then the next biggest, and then the smallest, or there's no exponent. So just to review a little bit, if we look at that linear term, the negative 3x, what exponent is on that x? A 1. Okay, so remember that if it's just a plain old x, it does have an exponent of 1 on it. The constant term, the 7, that's the one that does not have a variable with an exponent at all. It has an exponent of 0, so it's not even written there. So you'll notice that they labeled different parts of this. First of all, they labeled this 4 out in front the leading coefficient. So leading, it's in the front of the line. It's the leading coefficient. The x cubed term is the cubic term. Towards the end of last semester, we dealt a lot with quadratics. Those are the ones that are squared. Before that, we dealt a lot with linear equations. So the linear term is just the plain x to the first. And a number without a variable is still called a constant. Classifying polynomials by its number of terms. So we have 2 different ways of classifying. This first way is by how many terms there are. We already talked a little bit about this. If it's got just one term, it is a monomial. If it has 2 terms, it is a binomial. We saw a lot of those when we factored, right? Well, we put them in parentheses, but we saw a lot of stuff like x plus 2. That is a binomial. There are 2 terms there. So then we go up another. We've got 3 terms. That's a trinomial. For example, x squared plus 3x minus 5. I'm just going to make like a little column of examples. If you have 4 or more terms, so that's what that plus sign means, 4 or greater terms, we just classify it in general as a polynomial. So 1, 2, and 3 are the only ones that have special names: monomial, binomial, trinomial. Anything bigger than that is a polynomial. Now, what gets a little confusing sometimes is that you will also hear trinomials, binomials, and monomials referred to as polynomials as well. We could use polynomial for anything, but if we're asked to specifically classify, if it's got 1, 2, or 3 terms, we would want to use those names. Okay, so for a polynomial, we could have something like x to the 5th minus x cubed minus x plus 5, something like that, just 4 or more terms. Notice that terms are always split up by either an addition sign or a subtraction sign. That's how I can count my terms. We'll practice that more in just a little bit. When we classify a polynomial by its degree, we have a few more options here. You saw some of these in the notes up above with that big long example. If the degree is 0, meaning the exponent is 0 or it does not have a variable at all, it is a constant. If the highest exponent is 1, it is linear. 2 is quadratic. Those ones are the ones we're more familiar with: constant, linear, and quadratics. The ones we have not dealt with as much so far would be 3, 4, and 5. 3 is cubic. You probably have at least heard that before at some point, maybe. 4 and 5 are less common. 4 is quartic, and 5 is quintic. Now, if you've taken Spanish, some of this might seem a little familiar, right? Like 4 is cuatro, quartic. 5, quintic. I don't know, they kind of sound a little similar. On all of these examples, we want to first write it in standard form, then classify it by both its number of terms and by its degree. So we've got 3 different things we got to do on these. Put it in standard form, classify by the number of terms and by the degree. Number 1, to put it in standard form, we need the exponents to be in descending order. We've only got 2 terms here. I'll give away that hint right now. So we need to rearrange it so that the 5x to the 4th comes first. Is the 5x to the 4th positive or negative? Positive. So even when we rearrange it, it's going to stay positive. And then the 7x, is that positive or negative? Negative, so it keeps the minus sign with it. So this would be standard form. Questions about standard form? Okay, I already kind of gave away the fact that this has how many terms? 2. Okay, if you have trouble identifying the number of terms, what I recommend is to start underlining, but every time you come across an addition or subtraction sign, you pause. You don't underline under those. So I start underlining. Oh, there's a subtraction sign, so I pause. Start underlining again. I underline 2 terms. So 2 terms means that it's classified as what kind of polynomial? A binomial. And if we are classifying it by its degree, we look for the highest exponent, which is 4, and we looked at our little chart, and it would be quartic. That's it. That's all we got to do. Rearrange it in standard form and classify it by the number of terms and by its degree. Which, if you've already put it in standard form, in order to classify it by its degree, you should just have to look at the first term. I want you to give these ones a try on your own, but what do you notice about numbers 2 and 3?
There's multiple. There's 4 and there's 3.
We can combine like terms, okay? So make sure you combine like terms first, or at least combine like terms before you classify it. If you want to rearrange it and then combine, you can do that. But make sure your terms get combined before you start classifying. On number 2, we said that we had to combine like terms. Who can tell me what their polynomial was when they combined like terms and wrote it in standard form? Sadia?
3x cubed plus 2x squared minus 2x. I mean x squared.
Okay. And then, what came after that?
Minus 2x.
Wonderful. So if we combine the negative 4x and the positive 2x, that gives us a negative 2x. But we also had to rearrange it to be in standard form. So, oh, that was 3x cubed. That was my fault. All right. 3x cubed plus x squared minus 2x. Once it's in standard form, we classify it by how many terms it has. How many terms are there? 3, so we call it a trinomial. And we look for the largest degree or the highest exponent, which is also 3, so it is classified as cubic. All right, on number 3, we had to combine like terms, and really once you do that, it's pretty much in standard form. So on number 3, what did we get for standard form? Jacob?
5 minus 2x.
Can we make sure it's in standard form?
2x is 5.
Positive 2x or negative 2x?
Negative.
Okay. So the x term should come first. The constant term will always be the last thing. Always, always. So negative 2x plus 5. How many terms are there? 2, which makes it a binomial. And what is our largest exponent? 1, right? That x has a 1 on it. So if your largest exponent is 1, it is linear. On number 4, who can tell me what they got for standard form? Charles? For standard form? Good. Negative 2x to the 5th plus 6 is our standard form. I'm going to erase the problem above it so I've got a little more space to write. Okay, if negative 2x to the 5th plus 6 is our standard form, how many terms are there? 2 terms. Okay, we got the negative 2x to the 5th and the 6. 1, 2. 2 terms means it is a binomial. What is our largest exponent? 5, which means it is quintic. It's more important that you can spell it than you can say it. Okay. So number 4 is binomial and quintic. All right, the next little examples that we got would be a review of polynomial addition. This really is more of like an Algebra 1 skill or something that we would have done a little bit last semester. So what is important to do here is combine like terms. The key word here being like. So on example 5, this 3x squared in the front here is going to get added to what term from the second parentheses? The 4x squared. Okay, they have the same variable with the same exponents. So if we take 3x squared plus 4x squared, what do we get? 7x to what power? Squared. Combining like terms does not change your exponent. Keep the same exponent. The negative 6x can be added to the positive 2x. If we have a negative 6x plus positive 2x, we get negative 4x. The 7 in the back of the first set of parentheses can be added to the negative 1. What is 7 plus negative 1?
6.
Positive or negative? Positive 6. The 7 is bigger and it is positive, so it keeps the positive sign. So that's it. We combine the like terms and it's already in standard form. Even though it didn't say that, we should always put polynomials in standard form. The most accepted way to write answers in mathematics. Questions about example 5? Are we ready for the next one? All right. On our next example. Okay, so we're jumping down to review of polynomial subtraction. Our note there is to distribute the negative or subtraction sign and then combine like terms. So what that means is our first set of parentheses is not changing. So I'm just going to rewrite it. 3x squared plus 7 minus 6x. I'm going to distribute this subtraction sign in the middle to the whole second set of parentheses. So essentially that means all of my signs are going to change. So instead of a positive 2x, this just becomes a minus 2x or negative 2x. Instead of a minus 1, we're going to have plus 1. Instead of plus 4x squared, we would have minus 4x squared. We distribute that minus sign to the second set of parentheses. Now we can combine like terms. The 3x squared gets combined with the
4x squared.
negative 4x squared, giving us
Negative 1x squared.
negative 1x squared. All right, let's do the x's next so that we're in standard form. The negative 6x combines with the
Negative 2x.
negative 2x to give us
Negative 8x.
negative 8x. And then the positive 7 combines with the
Positive 1.
positive 1 to give us
8.
positive 8. If it helps you to like circle or box in the like terms, you can do that. Some people like to use like different colors. Like these ones went together. These two in the middle went together. And then your constants were left over. 7 and the 1. If you need to do that to help you organize your thoughts, that's fine. If you don't need to, don't worry about it. Do we have questions about how to do it? This should all be review. So I'm hoping that, I don't want you to be bored, but I'm hoping that this isn't like brand new, intimidating knowledge or anything. All right, next, I think this is our final example. Simplify and then classify by both term and degree. So this is putting it all together. We've got to distribute this minus sign here to the second set of parentheses. We have to combine like terms, make sure it's in standard form, and then classify it. So I'll give you a few minutes to do all of those tasks before we talk about our answer. Okay, let's at least start this process. Our first set of parentheses stays the same, negative a squared plus 7. When we distribute the subtraction sign, It's just going to make all of our signs change. So this 3a was positive, now it's negative. The 4a cubed was positive, now it's negative. The 2 was negative, now it's positive. So when you distribute a negative sign, it just flips the signs on all of those terms. So now the question becomes, what can be combined? The 7 and 2. Can anything else be combined? No. Nothing else can be combined because nothing else has the same variable and the same exponent at the same time. Okay, just because they have a's, that's nice, but they don't have the same exponent, they can't be combined together. If we are also going to try to write this in standard form while we're combining like terms, which term goes first? Caden?
Negative 4a cubed.
Negative 4a cubed. The cubed is our highest exponent, so it goes first. What follows it? Izzy? The negative a squared. What comes after that?
Negative 3a.
The negative 3a. And finally, we can combine the 7 plus 2 to get a positive 9. So we simplified it, put it in standard form. Next, we have to classify it by term and degree. How many terms are there?
4.
4 terms. Okay, we've got the cubed, squared, linear, or to the first power, and then the constant. So we've got 4 terms. We would call it a polynomial. Doesn't really have a special name once we get to 4 or more terms. And then our highest degree is 3, which makes it a cubic. Sometimes it's tempting to look at the coefficients, right? The coefficients don't really mean as much to us as the exponents when we are classifying. Yes, sir.
So if there is a subtract sign, then all the what's inside the parentheses change.
In the second set, yes. Yep. All the signs will change with that negative. Any other questions? Okay. That's the end of our notes.